Okay, excuse me. Welcome back. What I want to look at today is op-amp calculations. And what I'm looking at here is using the op-amp simply as a open loop gain amplifier. Now, the op-amp is a very useful piece of logic gate system, and it can be used for many purposes. So what I want to go for now is op-amp calculations, okay? Using the op-amp's open loop gain. Now, the output of an op-amp can swing positive and negative to a maximum voltage close to the supply rail potentials. Now, what that's saying is that it will operate at the potential of the voltage that has been applied to your supply rail. And obviously that can be maybe 5 volts, 24 volts, even up to 36 volts in some cases, or even higher. Yeah. Now, for example, the maximum output voltage for the popular 741 op amp. Now, remember there are various types of op amps, and I'm not going to give you a list of them here, but you can find a list of these on your search engines. Simply type in op amps and you'll find that there's quite a variety and different types. But the 741 is the one we normally use in a lot of electronics, okay, because it's versatile. Now, for example, the maximum output voltage for the popular 741 op amp when connected to a plus or minus 18 volt supply is 15 volts plus or minus. Okay. What that means is that it will operate if you have a voltage of 18 volts being applied to the supply rail, then you can reasonably assume you have a control voltage of 15 volts to play with. The system itself will use up some degree of voltage in its operation, so bear that in mind. Now, because the open loop gain of an op amp is extremely high, however, typically 10,000 to 1 million. Now, please note this is just a point of reference only. Okay, it can be greater than that in some cases or less than that in some cases, so keep that in mind. It is not fixed. It means that without negative feedback, any input that creates a difference in the voltage between the two input pins greater than plus or minus 150 microvolts, now that's microvolts, 150 times 10 to the minus 6, may be amplified by. So let's look at what he's saying here. What we're saying here is that because the op amp has such a high gain, you only need to put in a very small voltage, and the voltage that we apply is in the microvolts. That allows us to amplify this microvolt voltage into a very great deal, I would say, of a very large voltage. Bear in mind that the amplification ratio is quite high. And maybe again just feedback, any input that creates a difference in voltage between the two input pins greater than plus or minus 150 microvolts may be amplified by, for example, hundreds of thousands or more times and drive the output into saturation. The output will then appear to be stuck either at its. Now, when we say drive into saturation, what we mean to say is that we drive the amplifier to its maximum tolerance. That is not in our best interest. We need to have the op amp at a voltage which it can operate constantly. So we need to ensure that it is not driven into saturation. Saturation is not good for the op amp. Okay. And just to recap, for example, 100,000 or more times and drive the output into saturation. The output will then appear to be stuck either at its maximum or minimum values. Okay, and those values is determined by the rating of the op amp itself. Now, using the maximum open loop gain in this way can be useful when either dealing with extremely small and low frequency or DC inputs, or DC I should say. Okay. Now, inputs, instrumentation or medical applications are for comparing two voltages using the op amp as a comparator. In this mode, the output will go to either a maximum high or minimum low level, depending on whether one input is just a few microvolts higher or lower than a reference voltage applied to the other input. And here we have the op amp as a comparator. What we're doing here, we're putting two voltages input, V in, okay, and these will simply be voltages that we can reduce or control from some other source. Here we have our input sinusoidal waveform, okay, and that is on pin 2. Now here you have output pin 6, and that is the output pin of 6. Now what we're getting here, we're getting a square wave rectification in a sense here, okay. We're producing a square wave from a sinusoidal waveform. That is what the op amp in this case is doing for our voltage. Now this is the peak of the square wave, okay. It rises to maximum peak, then it drops, and it will remain in the negative position for a given time. It will rise again positively, but bear in mind the length of time here again can be controlled and governed by changing the time constant, okay. And again here it's dropped down, and again it will remain in a given position, and it will generate a square wave continuously along that lines from a sinusoidal waveform, okay. Vref, that is our V in, and those points they becomes our reference voltage. So here you simply apply your voltage that you're making a comparison to, but you have your V in still at this point, okay. Now these are quite good when you can actually put them onto a simulation, because you can actually apply a voltage here and you can see what's happening here, and you could drive other components with it, okay. That becomes quite excellent to do. Now this is figure 6.6.1 using an op amp as a comparator, okay. Now just pull back out again so that you can get everything in fully, okay. Okay. Now, basic op-amp types such as the 741 will perform adequately as comparators in simple circuits, such as a temperature controlled switch that is required to switch on or off a circuit when the input voltage from a temperature sensor is higher or lower than a preset reference value. Now look back at the figure I've just shown you. In figure 6.6.1, which is previously shown, and look back at it, a reference voltage is applied to the non-inverting input, whilst a variable voltage is applied to the inverting input. Whenever the voltage applied to pin 2 is higher than the reference voltage on pin 3, the output will be at a low voltage, only slightly higher than minus V supply. And if pin 2 is at a lower voltage than pin 3, the output voltage will be higher, slightly less than plus the supply voltage. However, standard op-amps are designed for low power amplification purposes, and if they are driven into then out of saturation, it takes some time for the output voltage to recover and for the op-amp to begin operating in a linear manner once more. So in short terms, if you once you utilize the op-amp, you need to have it set at the usage or voltages that you want to use it at. You can't keep driving it up and then driving it down and so forth. It will simply become, let's just say, inoperational. Okay, basically, it will not operate in a manner that will be beneficial to the circuit to which you are applying it. Okay, that's it. Thank you for your time. I hope you will have found this useful. Okay, bye for now. Bye bye.